Please welcome GlobalSense CEO Saeid Safavi.
Hello, everyone. I don't know why Zach made me angry here, but I'm not usually that angry. But my name is Saeid Safavi. I'm the CEO and co-founder of GlobalSense. We are an edge AI company with a mission to bring what we call sound sensing or acoustic sensing into the automotive industry as a new complementary sensory mechanism. And today, I'm going to talk about how sound sensing opens a new dimension in vehicle fault diagnostic and predictive maintenance, saving time, money, and improving safety. Well, the truth is every car has a voice. The question is, can we understand their language? And let me tell you a little story about how sound sensing became our center of focus here. Over 4 years ago, I was speaking with a friend, a real car guy, and we were talking about how modern vehicles have thousands of sensors for tracking their health and monitors to track their situation, and cameras to also monitor their surrounding. And then something struck me. We as humans have ears for a reason. So why don't cars have ears? Why can't they listen for faults like some technicians do, or hear events that matter for safety or security? So that question puzzled me for some time. I started looking around, looking at papers, publications, conferences, podcasts, name it. And I found almost nothing. So I said, well, maybe we'll do it ourselves. And as Franz Kafka once said, if it's not written, write it yourself. And 4 years on, after a long and challenging journey, I have the privilege to introduce you to our latest acoustic platform product. And basically, that will be the center of my focus of my talk today. Having said that, actually, that same friend, this journey started 4 years ago, as I said. That same friend is now part of our team in this mission. So going back to earlier days, we started focusing on security and safety events. So we were looking at events like car crash detection, car braking, window glass break, and events like that. And as a matter of fact, one of our customers today is mass producing this technology in their aftermarket tracking devices being sold worldwide. I will introduce that product in my next slide, but want to emphasize that the center of focus of presentation today is on vehicle maintenance. So that's the product I was talking about, which is an aftermarket tracking device for the very first time enhanced with an built-in on-device AI using our technology. The name of company is Positioning Universal. They're a well-established company building hundreds of thousands of these sensors, these trackers annually. So basically, what we did with them is integrate our hardware using Sentient chip with a very minimum bill of material so that it really didn't affect the overall price of the device as such. And this market is part of a $35 billion global market that is addressing, GPS basically tracking and collision detection. This technology usually use IMUs or accelerometers to detect crashes. Yet, almost up to 30% of collisions are missed through the accelerometer solution. And there are different reasons for it. For example, usually the technology fails to detect more complex crashes like side swipes or rollovers. And sometimes this could be fatal accidents. So our sound-based AI basically fill in this gap by, and this is a real critical gap, by detecting the actual sound of the impact and other, crash sound related, like, for example, tire screeching noise before the crash actually happens. And by doing that, we also listen to security events, as I mentioned, car break-in or glass break. So all of this results in a product that has more accuracy in terms of event detection, fewer false alarms, and more services, leading to a better user experience. OK, this, as I mentioned, the center of my talk would be on our newest device, which is called AutoSonix. Here is a 1-minute video to introduce.
Tired of the guesswork? When a car has a problem, you need answers fast. But what happens when even the best mechanics are stumped? Introducing AutoSonix, powered by GlobalSense, the simple solution to complex problems. It's the new tool that takes the frustration out of diagnostics. Forget complicated equipment. AutoSonix, powered by GlobalSense, uses advanced technology to instantly pinpoint issues, so you can fix the problem right away. With Auto AI Diagnostics, AutoSonix listens to your car's sounds and detects engine and transmission issues instantly. Our AI is lightweight, flexible, and runs anywhere: mobile, PC, or cloud. Device, app, and portal, working together to turn sound into intelligence. That's AutoSonix. It's the one tool that makes all the difference.
All right. So the fact is some major components of a car, like engine, transmission, or accessories, faults can only be detected through their sound. The problem is diagnosing cars with sound is difficult because the technician or person who, like inspector who checks the car, cannot, first of all, listen the sound from its source. It's usually contaminated with other sounds of the car or also environmental noise to start with. And then there are other parameters like time pressure, they need to finish the inspection in time, and also difference of experience make it even harder. And there's a paradox. The more experienced the technician is, then their hearing is usually weaker. And that's a real practical problem in this industry. But this leads to costly consequences. For example, auto auctions today lose millions of dollars annually in arbitration fees. And on the other hand, dealerships suffer from costly trading adjustments and also weaker, basically a lot of cost for repair labor that is wasted because of bad diagnostics. But the good news is, as the cars speak, every fault has an acoustic signature, kind of like a fingerprint in noise. The problem is humans cannot reliably pick it up. So this is where AI changes the game. AI listens with consistency, precision, and scale. It doesn't get distracted or lose hearing over time. It's actually exactly the opposite, because the more data it gets more and more powerful. So that's the opportunity to basically unlock a vehicle sound and turn it into actionable insight. To give you a better sense of how acoustic sensing is working in action, think of it like going to a doctor's office. A physician listens to patient heart or lungs, and that gives them a general sense of the patient well-being. But if there's something subtle or hidden, they need an MRI. They need a CAT scan to see what's really going on. And that's the same thing with vehicles. For example, in an auction setup, the technician who listens to the car for engine fault, can only detect 50 to 60% of faults. And this is based on our statistical data gathered over many measurements. While our model today is 90% plus accurate, because it sees the hidden patterns that exist in the acoustic signature where our ears miss. So basically, to give you a better sense of how it's working, I'm going to play for you a short sound clip of a vehicle with a fault buried in the noise of the vehicle. So it's difficult to hear it by listening to it, because humans listen to superposition of all the frequencies, not one at a time. But then I'll also play for you the AI extracted sound of that very same fault, that same vehicle, and you can hear the difference. And now the AI sounds go. So that little ticking noise is actually one of the major problems of engine. It's very costly to repair, but it's very difficult to hear it first time. So to conclude, this is not about substituting human, if you like, expertise, but rather, augmenting with a deeper view, same way like modern medicine does with advanced imaging. From our end user perspective, AutoSonix platform consists of three major components: device, app, and portal, seamlessly connected together to convert sound into intelligence. Our process starts with data collection phase, wherein the AutoSonix device collects high-fidelity audio and sometimes coupled with live OBD data. OBD means the onboard diagnostics that all the cars have an interface for. And then the data goes to the mobile app, and over there, we do data prep and fusion. And from there, the data travels to the cloud, where it undergoes labeling. Labeling could be automatic, could be manual. The label data, in turn, fed into the AI training pipeline, and then the train model would power the inference engines that could live in the cloud or directly on the mobile app. And for this, in this system, we have a very powerful front end and back end in collaboration with our partners like conditional software, Mimic microservices, Edge Impulse platform, and AWS backend. Okay, to show you the actual real-world impact for the auto auction use case, we put AutoSonix into test in pilot studies across 12 different locations in US and Canada. Each pilot study ran for 3 to 6 months, and it is long enough time for you to gather meaningful information so that you have information about different cars at different regimes and vehicle conditions to give more diversified, if you like, test scenario. 2 AI models were tested, and the results were very consistent. AutoSonix delivered accuracy margins of 30 to 40% over human inspector. And the diagram on the right basically shows what it means in practice. It's a diagram that shows the saving you can make with AutoSonix for this specific use case as a function of the number of inspected cars that the auction does per month. As you can see, for a decent auction size, usually, average, they do 15 to 16,000 cars a month. The saving quickly adds up to $1 million per month. And that's where I call AI starts to turn sound into real financial value. In terms of our vision, our our vision is to extend this technology into embedded acoustic sensors for OEMs and Tier 1 suppliers as a complementary sensory mechanism to many other sensors they have. And these could be like low-cost sensors that can be installed in different locations in the car and can detect anomalies or early faults through sound, and also can trigger more complex AI running at the edge. For example, our mobile app on a cell phone or the app on an infotainment system dashboard of the car. The goal is to alert the end user about early problems before they escalate to something bigger, because you hear the sound from its source, even a tiny one, and you can extract it, even if it's in other noises by AI. And that could definitely be, in support of predictive maintenance using this technology. Other use cases, for example, for OEMs is to use it in their software-defined vehicle, SDV platform, to prevent recalls by early detection of problematic components. It can even be used in production quality control as a mechanism to measure some anomalies during production. And of course, it can be added for other safety, security use cases inside the cockpit, outside the car, etc. All right, so this was the first part of my presentation, but I have a few slides to discuss our integration with Edge Impulse by focusing on the toolchain. Yes, that's the real work. Focusing on the toolchain, automated data pipelines, and custom blocks. So as you know, any AI system, one of the very first and important steps is data prep. And our data wasn't always clean. We had, some recordings were just simply bad. There were recordings that, again, the noise were buried in, the fault were buried in noise, or there were like multi-fault samples. Only about 20% of it were kind of easy to label. So for us to be able to do label, because here the labeling is very critical, and it's a very expert thing. It's not like listening to a glass break. You need to know exactly what you're labeling. We created a set of automated tools to address different aspects of the challenges that we were facing in terms of, for example, data prep, data segmentation, augmentation, and also accuracy checks. In terms of the Edge Impulse features, we found a lot of, the features there very valuable to us. Things like multi-impulse, data explorer, pipeline, expert mode, custom blocks, helped us with data prep and also model optimization, ensuring consistency, also detecting outliers, helping us importing data, and also build our own custom models and integrate it seamlessly into the workflow of the Edge Impulse. But being an AI company focused on sound, we also have developed our own internal tool set to analyze and prepare data in more sort of sound-centric fashion. Things like different flavors of sound augmentation, data set separation and classification, and some form of sorting and filtering. I don't get to the details of this because of time, but I would like to thank the Edge Impulse team and also our team at GlobalSense to build really a very robust tool set for automation and building product quality models in a fraction of usual time. And at this point, I would like to ask my colleague, our AI head, Dr. Alejandro Moran, to join me on the stage. He flew all the way from Spain to help me with the next few slides.
Thank you.
So I think, Alejandro, you've done a great work on these parts, but in interest of time, I'll go to the next slide and would ask you to discuss a little bit about what we do today for auto segmentation and auto labeling.
Yes, thank you. So I would like to go a little bit more in depth on how we are using the Edge Impulse platform in combination with our custom blocks. So we began with manual segmentation and labeling with the help of expert knowledge to classify this kind of audio, and in order to have a strong, robust AI model at the beginning. Now we transition to automated segmentation and labeling. We are implementing this as custom blocks within the H-Impulse platform, and our own data coming directly from the recording devices. As an example, I would like to show you a clip here for specifically for the segmentation part of it.
So this segmentation is done in real time on your platform for 36 or 38 second data clip or a song.
But this is only an example, only one of the steps. I would also like to show the whole pipeline here. So we start with the raw data from stored in S3. We have different files like file 0, 1, which we segment with the automatic segmentation block in segments that are meaningful to us, while filtering silence and noise. So for instance, here is 0, is 1, is 2, etc. Then we take each of these segments and assign meaningful classes related to car faults, or so that we assign to the audio, to each segment of the audio, if the car is healthy or has a transmission fault or engine fault, different kinds of specific faults. By the end of this process, we have a curated data set which we can import into existing or a new H-Impulse project and follow the training, evaluation, and deployment steps, closing the loop, and ending with a methodology which is consistent, which is reproducible and scalable. Well, that's basically it. With this methodology, we are transitioning from the manual segmentation and labeling bottleneck into a much more faster pipeline running in the cloud to accelerate the way to on-device artificial intelligence for our use case.
Yeah, and that concludes our presentation. I would invite everyone to join our demo table. We have a booth there on the other side. That is a very cool demo. We show all the process from data collection, the mobile app, all the way to upload it to cloud and the AI model analysis. So we'll be happy to discuss it in more detail with you guys. Thank you.
Thank you.